everyone! Ever wondered how applications efficiently store and retrieve information, like your user profile or a list of unique tags? Well, today we're diving into two fundamental data structures that are essential for any developer: dictionaries and sets. Understanding these will significantly boost your ability to write efficient and organized code. We'll explore their core concepts, how they differ, and when to use each one. Think of them as specialized containers, each designed to solve specific data management challenges. Dictionaries, sometimes called maps or hash tables, are fantastic for storing data that needs to be quickly looked up using a unique identifier. Sets, on the other hand, are perfect for managing collections of unique items and performing operations like finding common elements. Mastering these will open up new possibilities in how you approach data storage and manipulation in your projects. Let's start by looking at what makes these data structures so powerful. Let's kick things off with dictionaries, often referred to as maps or associative arrays in other programming languages. At their core, dictionaries are all about key-value pairs. Imagine a real-world dictionary. You look up a word, that's your key, to find its definition, that's the value. In programming, a key could be something like a user ID, a product name, or an email address, and its corresponding value could be the user's full profile, the product's price, or the email's content. The magic here is that each key must be unique within a dictionary, ensuring that when you use a key, you always get the precise value you expect. This uniqueness is what makes data retrieval incredibly efficient. Dictionaries don't inherently maintain any specific order, meaning the order in which you add items isn't necessarily how they'll be stored or retrieved. Their primary strength lies in their ability to provide fast lookups based on keys, making them ideal for scenarios where you need to quickly access information associated with a specific identifier. Next, let's see how we interact with these powerful structures. Working with dictionaries involves a few fundamental operations that are incredibly intuitive. First, adding a new entry is as simple as assigning a value to a new key. If that key already exists, you're actually updating the existing value. This flexibility makes dictionaries dynamic and easy to modify. To access a value, you simply provide its corresponding key. This is where their efficiency truly shines. Finding a value by its key is incredibly fast, even in large dictionaries. Think about retrieving a user's name by their ID, or a product's description by its SKU. And finally, if you no longer need an entry, you can easily delete it by specifying its key. This removes both the key and its associated value from the dictionary. These operations form the backbone of how you'll manage data in many applications, from configuring settings to storing user preferences. Now that we've grasped dictionaries, let's shift our focus to their unique cousin, sets. Now let's talk about sets. While dictionaries are all about key-value pairs, sets are simpler. Their defining characteristic is that they only store unique elements. Imagine a guest list where you only want to count each person once, no duplicates allowed. That's a set. If you try to add an element that's already present, the set simply ignores it, ensuring every item in the collection is distinct. Just like dictionaries, sets are also unordered collections. This means the order in which you add elements doesn't guarantee the order in which they'll be retrieved or iterated over. This unordered nature and the guarantee of uniqueness make sets incredibly useful for specific tasks. For instance, they're excellent for quickly checking if an item is present in a collection. This is called fast membership testing. Need to know if a specific user ID is in a list of active users? A set can tell you almost instantly. They are also powerful for mathematical set operations, like finding common elements between two groups. Let's delve into those operations next. Just like dictionaries, sets come with their own set of operations. You can easily add new unique elements or remove existing ones. The real power, however, lies in their ability to perform mathematical set operations. Ever needed to find all elements present in either of two collections? That's a union. What about finding only the elements that are common to both? That's an intersection. You can also find elements present in one set, but not in another, which is a difference operation. These are incredibly useful for data analysis and filtering. So, to recap our journey, dictionaries are for key value storage with efficient lookups, perfect when you need to associate data with a unique identifier. Sets, on the other hand, are for collections of unique items, ideal for membership testing and performing powerful mathematical set operations. Choosing between them depends entirely on your specific data management needs. By understanding when and how to use dictionaries and sets, you've gained two powerful tools that will make your code more efficient, cleaner, and more robust. Keep practicing, and you'll master them in no time. Happy coding!